All right, and our last lesson for this week, we skipped over to lesson 91, continuing our discussion of using proportions and proportionality and how that affects increasing the size of something or decreasing the size of something. We're talking about the effects of scaling on perimeter, on area, and on volume, and they have different effects depending upon which you're talking about. The thing to keep in mind, and this is crucial to having an understanding of this, make sure you get this in your notes, is that if you talk about perimeter, it is simply the scale factor times whatever the perimeter is. 1 to 1, all right? If you're talking about area, it's going to be the scale factor squared times whatever the original area was. And if you're talking about the volume of something, then it's going to be the scale factor to the third power times whatever the original volume was. And the reason for this is because perimeter are linear units to the first power, area are square units to the second power, and volume are cubic units to the third power. So it is not just if it's 3 times as big, the volume is not 3 times as big. The volume is 3 times 3 times 3 times as big, all right? When you talk about linear, yes, you just multiply the scale factor and now the length is 3 times bigger. But the width is 3 times bigger and the height is 3 times bigger also. So keep this in mind. This is the key relationship for this whole lesson. We take a look at something like a cube here that is a 2 by 2 by 2 cube, all right? We're going to decrease it. All right, we're going to shrink that cube by a scale factor of 1/4. It's still a scale factor. We don't talk about dividing. We're still multiplying here, except now we're multiplying by a fraction less than 1, which is going to make the numbers get smaller. Fine. All right. So in this example, all right, I want to know what this new cube's going to look like as far as perimeter, area, and volume go. Well, right now, if we look at the perimeter of the top of this square, it's 8. And it has a scale factor of 1/4. So to find the new perimeter, I'm simply going to take the scale factor, 1/4, times the perimeter, 8, and we get a new perimeter of 2. All right? Because the perimeter here starts off as 8. 8 times 1/4, 8 over 4, simplest terms, 2. When we look at the area of this cube, if I'm just looking at the area of the top square, for example, then what I'm talking about is 1/4, the scale factor, squared times the area 4. And now it's 1/4 times 1/4, or 1/16 times 4. So now that area has gone down to 1/4. And finally, if I'm looking at the volume of the cube originally is 8, 2 times 2 times 2. But the scale factor now is going to get cubed, 1/4 to the third power, which is 1/64 times the original volume, 8, and now we see that that new volume is 1/8 of the original one. Okay. Other problems that might use this, a building is made of Lego cubes, and it took 200 of these Lego cubes to make this building. So now you want to double the size of that building, dilate it, all right? How many Lego cubes are you going to need? Well, you're going to need the volume, 200 cubes, times the scale factor to the third power. The volume now is 200 times 2, the scale factor, to the third power. 2 to the third power is 8, 8 times 200. You're going to need 1,600 blocks. You can't go out and say, oh, I'm going to double the size, so now I need 400 blocks. No, it doesn't work that way. Because you're doubling all 3 dimensions, you're going to need a whole lot more blocks to do that. All right. Another example would be using percentages in dilation. All right. We have a rectangle that we want to dilate 50%. All right, big deal. We're just going to change 50% into a scale factor of 0.5, but remember that this is an increase of 50%. So what I'm really getting here is the scale factor is the original amount, 1, and 0.5 added to it. So the scale factor becomes 1.5 times the dimensions. And so if I'm going to dilate this 6x4 rectangle by 50%, I have the original dimensions times not 0.5, because that would be shrinking it, not dilating it. You have the original amount and 50% more. That's where we get 1.5. So I've got 6 times 1.5, the new dimension is 9. 4 times 1.5, the new dimension is 6. So the perimeter, I mean, if we looked at the perimeter here, we would see 6 plus 6 is 12 plus 8, so the perimeter is 20. And we would take 20 times 1.5, so the new perimeter here should be 30. 9 plus 9 plus 6 plus 6, what do you know? Perimeter equals 30. 20 times 1.5. The original area here is 6 times 4, 24. This area should be 1.5 times 1.5 more, 2.25. So 6 times 9 is, the area here is 54, and 54 times 24, or 24 times the scale factor squared, 2.25, is indeed 54 square units. So these are the types of problems you would see in this lesson 91, A through H. You got 3 lessons to work on. There'll be more posted coming next week. Bye.